We're going to pick up where we left off last time in section 7.4. We were talking about interest. And I think that we had just gone through these formulas and done one problem. Does that sound right? Problem 8 or example 8? Great. So we're moving on into number 9. Just a reminder real quick, let's go through the formulas. How do you know if you're going to be dealing with simple versus compound interest in a problem? It will say. Look for it. There's no tricks. Okay, it will say one of the two words. Look for it. All right, so let's take a look then at Johnny and Carolyn. Johnny and Carolyn have 3 savings plans that sum to the following interest in 1 year. The first one, a passbook account, made $53.90 on a principal of $980. The second one, a CD, made $55.20 on a principal of $600. And the third one, a money market, paid $158.40 on a principal of $1,200. Which account paid the best annual interest rate for the year? Okay. I use this example because I want you to see that it sounds like this problem has to do with interest. And it does, but it actually is far more related to the percent section that we did than the interest section. So let's take a look and show how this works. All right, so the first one, the passbook account. We know that the passbook account makes $53.90. And we also know that the original amount that it was invested was $980. And what we're wanting to know is which one makes or has the highest interest rate. Okay? This is a problem a lot like those tax problems you guys were asking about. We know it makes $53.90 in interest. That's the interest amount on the original balance of $980. And that $980 is 100% of the investment. And what we're looking for is the interest rate. I'll call it R just for good measure, but you could use an X if you'd like. That's a 1?
Oh, it's a 1.
Yeah,
Sorry.
from up here, a 1. Okay, so we're going to cross multiply, right? 980R equals 5,390. So what happens when you divide this? What was it, Leah? 5.5 what? Percent. Yeah, it's a percent that we found. This is the percent of a value when the values are known. Looking for the percent. So the first interest rate on the first investment is a 5.5% interest rate. We're going to do the second one, and we're going to do it the same way. The second one has a CD. It makes $55.20. On an original investment of $600. And that's 100% of the value of the investment. And again, this is an interest rate, so I'm going to use R. So 600R equals 5,520, and we'll divide. So what is 5,520 divided by 600? 9.2, and it's a percent. Very good. All right, so I'd like for you guys to do number 3, and then we'll make sure everybody has the right values when you're done. You have the third account. It's a money market. Makes $158.40 on a principal of $1,200. So find for me what you believe the interest rate would be on that account. Thank you. Okay, did everybody set it up like that? Good, and you cross and multiplied, and in the end, what did you end up with the R value on this one? Yeah, it's 13.2%. So careful on that one. It is 13% and some change. 13.2. So the question actually asked, which account, make sure you answer the question asked. I mean, like, we've done all the math to support the answer at this point. We haven't answered the question. The question actually said, which account paid the best interest rate? The money market. Make sense? Okay, so it's involving interest, but it wasn't talking about simple or compound. It was a comparison of things in their interest rates. All right, the next problem does not quite look like an interest problem, but it can be solved very much like an interest problem. So we're going to take a look at this. A publishing company signed an agreement to allow a textbook, first edition, 500 pages, to expand over several editions until it's 1,000 pages long. The textbook's growing at approximately 10% in the number of pages over each edition. How many editions could be published before it reached the contractual limit? Okay, so let's just write down a few details and see if we can get a feel for how this is connected to the ideas we've been doing. Because it sort of looks like it's not talking about interest, right? And it isn't, but it has a lot of the same features to it. So the first edition has how many pages? 500. How would I find out how many pages the second edition has? I would add 10% to the number I already have, right? So what's 10% of 500? 50. So this would be 550 pages. And the reason we did that is because we did, in fact, I'll write it that way. 500, the original 500, plus 50 more. Right? Okay, so the third edition, we'll go a couple more into this before we sort of step back and look at the pattern. Third edition takes the 550-page book now. Okay, we're not just adding 50 every time. It's 10% of what the new value is. So what would the 10% amount of 550 be? 55. So then the fourth edition of the book would start out with how many? 605. And then we would add to it what? Yeah, 60.5, and we're not super interested in half pages of things, so we're just going to round. It's going to say 61. 61 pages. Okay, so every time what we're doing is we're taking the previous amount and we're multiplying it 0.10. Previous amount multiplying by 0.10, right? You guys with me? That's compound interest. At least it's the same process as finding compound interest. So let me show it to you in terms of a formula so you can see what happens if you think about it that way. So let me, well, actually before I do that, could you continue this process for however many editions until you hit 1,000? Absolutely you could. Okay, and that's totally fine if that's what you choose to do. There's nothing wrong with that. If you wanted to go out to 2,000 pages, it would probably end up taking you a while, right? 1,000's not too bad. The books get, you're going to tap it out at about 10 or 11 editions, 8 editions, it's somewhere in that. So this won't take forever. But let me show you a cleaner, nicer kind of way of thinking about it. So this is compound interest, because what compound interest is it's taking interest on your interest. So let's interpret these variables in terms of this problem and what they actually mean. What do you suppose P represents in this problem? 500, the original page number, like an original deposit at a bank. What do you suppose the R represents? The 10%, it was 10%, yeah. The 10% increasing value, right? So it's 0.10 on R. Any idea what N would be? This is the weirdest one.
Number of times, so that would stay in.
Close.
Wouldn't you not know?
We do know what N is actually.
And how many additions are?
It's
not you're compounding the
Yeah, okay, so it's actually not how many times you're compounding their pages. N is going to be how many times you apply the 10%. That's not, I didn't even say that right. Let me start again. N is going to be the 10%, like when I apply 10%, I apply it every single time once, right? It's 10% per addition. So this is the number 1. The T is the one that you guys are wanting to do. T is the number of additions. So in this problem, this would be my number of additions. Okay? So why does it matter? Well, because if you simplify this equation, you end up with 1.1 inside. We're going to talk about how you can think about this as well, to the T. So let's think about this in terms of something you've seen before. Do you guys remember geometric sequences? Where you took a number and you raised it to a power? Because all a geometric sequence really is multiplying by a power, the same power over, not power, but the same number over and over again, which creates those exponents. That's what this is doing. This is a geometric sequence. Every single time, I'm multiplying by 1.1. So why 1.1? Well, what is 1.1 as a percent? 110%. What is that as it relates to this problem?
It's the full thing plus 10%.
It's the full product that you originally have plus 10% more. Isn't it? So why does it matter? Well, it matters because if you actually wanted to figure out what number to use and you want to do it the way that's on the left, I have to do every single addition until I get to 1,000, correct? If I think about it from an equation standpoint, I could use this equation and I could just plug, not random numbers in, but I could plug numbers in for T until I hit 1,000. You guys with me? So grab your calculator, just take a look at this. I would like for you to do 500, do your parenthesis, 1.1. Most of you have calculators that will do that. If they won't, that's fine. And then you want to raise it to a power. So maybe you raise it to the power 7 or 8 or 10. What you're looking for is the closest you can get to 1,000 without going over, because that's the contractual limit. They're not going to produce a book that's more than 1,000 pages. That's what the problem tells us. So what is the biggest number you can get that won't go over? 7 is right. So if I put in the number 7, or you put in the number 7, what did you get? 974. And if you tried 8, what did you get?
1,071.
And this is too big. Too big. Now here's the catch. We haven't actually given the answer to the question. The question says, oh, hang on. The question says, I'll ask it that I was about to ask it, and then we'll talk about it. The question says, how many editions could be published before it reaches its contractual limit? We're tempted to say 7. It's actually 8.
This is really confusing.
Let me tell you about why, though. Because you start with edition number 1 at 500 pages. What number would you have to plug in for T in this formula over here to get 500? 0. If you plug in the number 1, what does it actually give you? If you put the number 1, 500 times 1.1 to the 1, what does that give you? 550, which is actually the second edition's value, right? It's the second edition's value. And here is what we did when we saw this before. Do you remember when we did geometric sequences, we didn't put just n up there at the top? Do you remember what we put? We put n plus 1. Y'all remember that? Or n minus 1? What did we put? N minus 1. Sorry, n minus 1 was our exponent. If we actually used our exponent as n minus 1, then we would have 8 minus 1, which is our 7 for the 8th edition of the book. If you write these out, or if you weren't for sure, once you get to the 8th one down here, you will see that you have the 974 pages. Here we go, pages. So it's actually the 8th edition of the book. All right, one more question. Again, it doesn't quite feel like interest, and it isn't, but it's related so well that you can still use the same concepts to solve the problem. Because of a recession, the value of a new house depreciated. What does depreciated mean? Went down. It went down in value 10% each year for 3 years in a row. Then, over the next 3 years after that, the economy starts to recover. The house increases in value by 10% per year. Did the value of the house increase or decrease over or after the 6 years?
Stayed the same.
It'll be the same thing. It goes down to 10, 10, 10, 10, 10, 10.
But then over 6 years, it would go 30%.
It went down 3 and then went up 3.
You guys are so engaged with this. This is fun. We're going to check it out. We're going to do the math to see what happened, okay? Because it is very natural to look at this and think it should have stayed the same. Down 10% 3 times, up 10% 3 times. It should be back where it was before. So let's take a look and see how that works. I don't know something in this problem that I kind of need to know to do anything with the problem.
What it was before.
Yeah, I don't know what it was to begin with, right? I don't really care what it was to begin with, honestly. I can pick whatever I want. I'm going to make a comparison of where it was at the beginning to where it was at the end. So I'm going to pick a nice, easy number to work with, and I'm going to pick a $100,000 house. You guys good with that? $100,000. Nothing special, it's just easy to work with. So my initial amount of my house, if you will, at year 0, okay, is $100,000. We're going to think about this in terms of these compound interests, okay? So the first year, it goes down 10%. Well, all of my interest formulas are interest that's above, right? It all went up. So when you take a look at the compound interest formula, this one right here that's written here, it has 1 plus R over N business. Basically, we're going to have 1 minus, yeah, because it's actually depreciation. So think about it with me. What would I need to multiply the 100,000 by to find out the new value? Not how much it went down, but the new value. It went down 10%, 90%. Okay, so in terms of a formula, this is what you were just saying, Leah, the subtraction. Oops. This is the 100,000 that we're looking at. And we're doing 1 minus the 0.10%. And it's the time in years, T. So this value inside of here is actually 0.9 because it's 1 minus 0.1. Or you can think about it as being 90% the value it was before, right? 90% of what it was before. Okay, so what does that look like? Well, what it really means I'm doing is I'm taking this 100,000 times 0.9. So how much is this house worth after 1 year of depreciation? 90,000.
Where did we get the 0.9? We did the 1 minus 0.1.
Yeah. So this is year 1, after year 1, right? It's worth $90,000. How about year 2, after year 2? What would I have to do? It'd be 90% of 90,000. Or you can take the 100,000 and simply do the 90% twice. Right? Because 100,000 times 0.9 was the first year, and then I wanted to multiply it by 90% again, a second time. All right, so what happens if I take 90,000 times 0.9, or if I take 100,000 times 0.9 squared? What do I get? 81,000. So the first thing I might want to warn you of is, did you notice that is not 20% of what it was originally, right? It's not a 20% decrease, so it is not compound percent. You guys with me? All right, let's do year 3. This is our last year of depreciation. What am I going to do to find this value? Yeah, 0.9 to the third power. You guys got it. So what would 90%, oops, of the 81,000 be? Or what is this value, 100,000 times 0.9 to the third? 70,900. Again, that's not a decrease in 30% in the price of the house, right? It doesn't work quite like that. This is going down in value 10% every year, but then for the next 3 years, we're going to go up in value 10%. So it'll be 1.1. You got it. All right, so here's where we are. I'm going to go to the next slide. I thought I was. I'm out of space. All right, we'll try and squeeze it in over here. All right, so we're going to go up in value next. So like you said, it's going to be, this is year 4 after the 4th year. So we're going to take the 100,000, not the 100,000, I'm sorry. We're going to take the 72,900 because the increasing price is based on the value it is now. It's not worth $100,000 now. It's starting at 72,000 when it starts going up, and it is increasing by 10% per year. So now I have 1.1 instead of 0.9. And we'll do this to the power of 1. Why did I put 1 there and not a 4? Yeah, I'm only in the first year of appreciation, right? I mean, it's the 4th year of owning the house, but it's only the first year of it going up by 10%. Okay, so if I mark this out, what do I get? 80,190. All right, let's do the 5th year. What would I have to change in this formula for the 5th year? Squared. Yeah, I would do the same thing and I'd square it because this is the 2nd year of appreciation. What's that give you? All right, 6th year. Same thing to the 3rd power. What will I end up with? Let's just say $30. Is that okay? Or round to a whole dollar amount. Did the value of the house increase or decrease after 6 years? It decreased. Make sure we answer the question asked. The answer is that it decreased. But we need all that work to support why we believe that's the case, okay? All the work was necessary to answer the question that was asked, that it decreased. One other question that's being asked now. This kind of brings all the pieces of this problem together. We made something up in this problem. What did we make up? The $100,000 house, right? So we couldn't look at this, for instance, and say the price of the house decreased by $2,000 or $3,000 or $5,000 because we made up the price of the house. So take a look at part B. It says, by what percent did it decrease or increase over the 6 years?
Could you do it like the one we just got, the original, and then
Like this? A proportion? I think that's a great idea. Okay, so what's going to go in the bottom? 100%. I mean, what is the 100% value that we're talking about? The original amount that we chose, the $100,000 house, which it's our made-up value. We're looking for the percent, so this is the x. This is what we don't know. What's going to go on top of the other side? It could. We'll do the problem that way. 97,000. What was it? $30 if I rounded. I don't think that looks very good, but there we go. It's better. All right, what am I going to find if I do this? I mean, the answer you're going to find is something like 97.03% or 97-ish%, but did that answer the question that was asked?
You're going to subtract it from 100 to
You would.
How much it decreased.
All right. So then we'd have to do 100 minus the 97.03 to give us what? 12, I'm sorry, not 12, 2.97%. Okay, why did we do that?
Because it just gave you how much it was worth now of the previous price rate.
Right. The 97% that we found in this problem is the value that the house is worth now of the original price. There's another way we could have set this up though. Does anybody see another option now where we could have found the 2.97 immediately and not had to do the subtraction at the end?
You done 410. Or would you have done 9?
Would you subtract at the beginning, would you have found out what the difference was between the 100,000 and the 97, and then balance off the 97.30?
Yes. So I'll repeat that so that everybody can see it while I'm writing. All of this is fine, but what we could have done is we could have been a little bit more aware of the value it was asking us to find from the beginning instead of at the end. It wants to know the value of the house, sorry, not that, the percent it decreased or increased over time. So what we could be putting on top here, right here, is the amount that it increased or it decreased. In fact, if we're super careful and we put the amount that it increased or the decreased, we might even write it in there as a negative to remind ourselves that it decreased. You wouldn't have to, but you could. So it decreased $2,970, right? That's what it did out of $100,000. And if we find it from this perspective, we'll get the 2.97 from the get-go.
How do we-
Somewhere along the way, you got to subtract.
How do we know the 2,970?
Where did the 2,970 come from?
97,030.
Yeah. It's the subtraction of these two quantities, Hannah.
Okay.
The amount that it actually changed is what's on top. And we subtracted it from the original amount we picked. All right, any questions on that one? All right,